science, we have the use of math. And in math, we have the use of language, since we do have word problems and reading. In music, we use a lot of science, and sometimes we use math as well. So right now, we're going to talk about music. So we have sounds here through music. We have low pitches, high pitches. We can also play quiet sounds and loud sounds. So the way sound is produced is through the vibrations in the air. So the air is displaced, the air molecules are displaced through the vibrations of whatever you're playing through. So it could be singing, it could be a stringed instrument, it could be a piano, they all do the same thing. So on this instrument, you can physically see the vibrations in all the strings. So without the strings moving, you do not have the displacement of the air, and there'd be no sound. So without air, there wouldn't be any sound either. So we have these bigger strings that produce our low sounds over here. Then further, we have these skinnier strings that produce our higher pitches. And so just like we have high and low, we also have loud and we have soft sounds. All right, so now that we know we have low and high and soft and loud, we can also combine them. So we can always play a low quiet sound, just like we can play a low loud sound. Same goes with the high. You can do louder and you can do softer. Just like when people speak, sometimes you hear a really low voice that can be really loud. Sometimes you hear a high voice that's really quiet. So that can all combine. And so when we have these high pitches, they're also known to have a high frequency, which in science we measure them with hertz. And then for low ones, still hertz, just gonna have a different numerical value. And so the way we measure volume is a little different. We have these things called decibels. So the higher the volume, the bigger the number is gonna be. Just like when something is quieter, the smaller the number is gonna be as well. So the next thing we're gonna talk about is how our ears perceive these sounds.
So you guys might be wondering how we hear. Here I have a diagram of the human ear. The human ear is made up of three parts. You have the outer ear, the middle ear, and the middle ear. The outer ear is made up of your earlobe and your ear canal. The middle ear is made up of these three bones, and the inner ear is made of the cochlea and your auditory nerve. So pretty much what happens as you hear a sound wave, it's going to be directed into your outer ear, and your outer ear is going to funnel it and direct it into your ear canal. The ear canal is from the ear canal, it's going to move and vibrate the eardrum. Like this. These vibrations are going to be translated into the middle ear, into these small bones. The malleus, the incus, and the stapes. These small bones will transfer the information to the cochlea. In the cochlea, we have a liquid. And inside the cochlea, we have something that's called the basilar membrane. As the liquid vibrates, it's going to hit these hairs in the basilar membrane, and they're going to bend. And when they bend, they transfer a signal into the auditory nerve. So that's how we hear sound. But you may be thinking, how about frequency when it changes? When you have a higher frequency, it's going to be transmitted on the outer cochlea, the snail portion, like a loud scream, high-pitched scream. When you have a low pitch, like a dog barking, it's going to be on the inner part of the cochlea, up here. Now you may be thinking, how about volume? Volume is translated in terms of how rigorous the basilar membrane inside the cochlea vibrates. If you have a loud volume, it's going to vibrate more vigorously. If you have a low volume, it's going to vibrate. Now that we learned a little bit about what sound is and how the human ear processes sound information, you might be wondering, so what about the math part? Well, with math, we can use waveform to analyze the sound and what happens in terms of frequency and decibels.
How do we know how sound travels in air molecules, or air, and how the ear processes it? Now we're going to take that data and make it tangible. And the way we do that is by utilizing wavelengths visually. So wavelengths, they have three components that we're going to talk about today, which is the period, which is really just another word for time. Frequency, which is measured in hertz, it's cycles per second, and it also shows on both of these graphs. One is a low frequency, and you can see the peaks and the valleys are far in between. And in the high frequency, they're more condensed. And that's what we're referring to as frequency. Amplitude is how high those peaks are. And what we're really concerned about in this lesson today is the realization that even if we have the same amplitude, even if these peaks meet at the same spot, they can still have a different frequency. And this is what that would sound like again with sound. Low frequency would be, and a high frequency would sound like this.